Today I'm going to show you about Ka, Kb, and Kw and their relationships among them, and how they're useful when solving equilibrium problems. So if we take the dissociation of liquid water, that's going to break up into its ions of H+, aqueous, and OH-, also in the aqueous phase. If we write the constant for this reaction, it's going to be H+, concentration of H+, times the concentration of OH-. And then we would normally do over the reactants, but we never include pure liquids or gases in the equilibrium expression, so that's just it. And no matter what these concentrations are, there's always a ratio that makes their product equal to 1 times 10 to the negative 14th. So that's your K for this. And that, since it's a constant, we call it Kw. So that's the equilibrium constant for the dissociation of water. Now, there also is a rule that says Ka times Kb equals Kw. And I'm going to show you how that's true right now. So, if we have the dissociation of a general acid, HA, that goes to H+, aqueous, and A-, also in the aqueous phase. And its expression is the concentration of H+ times the concentration of A-, all over HA. And you've been introduced to this before, so that should be familiar. And then if we want to take the reaction, the equilibrium reaction for this conjugate base, it will be written like this. It's pure liquid. And then this water is going to split up, and one of the protons is going to go with this A. So you have HA in the aqueous phase, which is your general acid. And then the OH that's by itself is just going to be an ion. And if we write this expression, it's going to be something that you're also familiar with. Concentration of HA times the concentration of OH-, all over, again this is a pure liquid so we don't include this, so we only have the one A- aqueous. So now, I want to try to multiply Ka and Kb. And all I'm doing is taking these directly from the equilibrium constant expression. As you can see, we have some like terms that we can cancel out. So your acids cancel out. I'm sorry, your A-minuses cancel out. Your general acids cancel out. So then you're just left with concentration of H+ times the concentration of OH-. And if you look here, this is the exact same thing as we got for Kw. So there's your derivation of how Ka times Kb equals Kw. And this is really useful in that whenever you're given all of the equilibrium information for like an acid, then you can find anything that you want for the base with this constant here. And vice versa, if you're given everything for a base, then you can find the information for an acid. Thank you.